American science fiction disaster film The Day After Tomorrow. Remember that the UN officials largely ignored climatologist Jack Hall, who presented his environmental concerns about an enormous superstorm that would set off a catastrophic natural disaster following the disruption of the North Atlantic Ocean circulation. Although that was just a movie, scientists all over the world are not ready to ignore any warning signs that may spell danger in our world. Also, people have expressed much concern over the warning that the Gulf Stream is finally collapsing. So without further ado, let me show you what the Gulf Stream actually looks like and how it travels. The Gulf Stream, along with its northern extension, the North Atlantic Drift, is a warm and quick-flowing Atlantic Ocean current that rises in the Gulf of Mexico, passes through the Straits of Florida, travels up the east coast of the United States, takes a nice turn east about 36 degrees latitude, North Carolina, and finally travels toward northwest Europe as the North Atlantic Current. The Gulf Stream is a northward accelerating stream off the east coast of North America as a result of the western intensification process. It divides into two streams around roughly 40 degrees north, 30 degrees west, with the southern stream, the Canary Current, circling off West Africa, and the northern stream, the North Atlantic Drift, traveling to northern Europe. In recent times, when you flip through the pages of newspapers and magazines, watch the TV, or even browse through your smartphone, one of the things that you'd most likely come across is news about the Gulf Stream and what could become of it. To this, many believe that the Gulf Stream has a bigger impact on the climate of northwest Europe than it does on the coastal regions of the eastern coast of the United States, which spans Florida to southeast Virginia around 36 north latitudes. To me, it looks like the whole world held a roundtable meeting and came to a consensus because the majority of people believe that the robust North Atlantic Current is at least largely to blame for northwest Europe's warmer climate than other regions at a similar latitude. However, some experts say that there are other factors to consider other than the North Atlantic Current. So let's now take a look a few meters deep into the history of the Gulf Stream. You see, the Gulf Stream was first observed by Europeans during Juan Ponce de Leon's trip in 1512, about 5 centuries ago. Following the discovery, Spanish ships bound for Spain from the Caribbean began to frequently make use of it. As they kept on using it, they began to learn new and fascinating things about the Gulf Stream. However, on April 22, 1513, Ponce de Leon recorded in his journal that they were faced with an unexpectedly great current, so great that they could not advance forwards, despite the fact that they had considerable wind. As the fearful drama unfolded, it looked as though they were progressing well, but in the end, they discovered the current was stronger than the wind. Later on, the circulation patterns of the North Atlantic Ocean piqued Benjamin Franklin's interest. Franklin was in England in 1768 when the Colonial Board of Customs made a puzzling complaint about why British packets from England would take several weeks longer to get to New York than the typical American merchant ship took to get to Newport, Rhode Island. This complaint was triggered by the fact that the commercial ships leaving from London had to travel down the River Thames and then travel over the length of the English Channel before sailing over the Atlantic, whereas the packages only left from Falmouth and Cork. Now, two studies that were published in April 2018 claim that the Gulf Stream is at its weakest point in at least 1,600 years. The study discovered that the current known as the Atlantic Meridional Overturning Circulation, AMOC, is on the verge of completely losing stability during the last century. The new analysis indicates that although the current's already at their slowest rate in at least 1,600 years, they may be on the verge of ceasing altogether. This new study has sparked many reactions over time because such an occurrence would have disastrous effects on the entire world, severely disrupting the rains on which billions of people in India, South America, and West Africa rely on for their food. Furthermore, it could bring about intensifying storms and bringing on colder temperatures in Europe and raising the sea level of eastern North America. To crown it all, the Antarctic ice sheets in the Amazon rainforest would definitely have their share of the cake, as both would be put at an even greater risk. The truth is, it is now hard to predict the exact date of collapse, if there ever would be, due to the intricacy of the AMOC system and the uncertainties surrounding future degrees of global warming and other environmental factors. Do you think it might happen in the next few years, or do you think it might take several centuries? Well, before I give you an overview of what it will probably look like in the end, let's see what experts have to say. Researcher Nicholas Boers of the Potsdam Institute for Climate Impact Research in Germany said that he wouldn't have expected the warning signals of destabilization to be so obvious by now, and that he finds this worrisome. And in his opinion, this is something the world simply cannot permit to occur. According to him, it is unknown what amount of CO2 concentration would be enough to cause the AMOC to collapse, so keeping emissions as low as feasible is a major course of action. And Nicholas Boers is not the only one with this point of view, because I've seen and heard several people similarly talk about this. People believe that every gram of CO2 that we add to the atmosphere enhances the possibility that this extremely high-impact catastrophe will occur. The AMOC has two states, one that has been fast and robust recently, and the other that has been slow and feeble during the previous 100,000 years, according to ice core and other evidence. According to the statistics, over 1 to 5 decades, rising temperatures can cause the AMOC to quickly change between states. The melting of fresh water from Greenland's ice sheet is slowing the AMOC process down earlier than predicted by climate models, and the AMOC is fueled by thick, salty salt water sinking into the Arctic Ocean. These indications of declining stability are worrisome, according to David Thornalley of University College London in the UK, whose research revealed that the AMOC is at its weakest point in 1600 years. But then everyone is still puzzled. We are still unsure of when or how soon a collapse might occur. Nevertheless, let's examine the Gulf Stream's effects on its locality. One of the most important benefits and effects is that the Florida Peninsula's climate is influenced by the Gulf Stream. Throughout the winter, the Florida Current, a section of the ocean off the coast of Florida, maintains an average water temperature of at least 24 degrees Celsius. Warm air from the Gulf Stream is transported inland by easterly winds passing over this warm ocean, keeping wintertime temperatures in the state milder than elsewhere in the southeastern United States. Furthermore, because Nantucket, Massachusetts is warmer in the winter than the mainland, the Gulf Stream's closeness to the island increases its biodiversity because it serves as the southern limit for northern plant species and the northern limit for southern plant variations. Also, Ireland and the west coast of Great Britain are kept a few degrees warmer than the east by the Gulf Stream's North Atlantic Current and other warm air currents. Yet Scotland's western coastal islands are where the divergence is most noticeable. Around the Norwegian coast, the Gulf Stream and the strong westerly winds have an obvious impact on Europe. Norway's northern regions are adjacent to the Arctic region, which is mostly covered in ice and snow throughout the winter, but practically the entire Norwegian coast is never covered in snow or ice. Several sizable villages, including Troms, the third largest city north of the Arctic Circle, have grown and been maintained along the Norwegian coast thanks to the warming impact of the Gulf Stream. Climate change is occurring behind the Scandinavian mountains as a result of weather systems warmed by the Gulf Stream drifting towards northern Europe. Now let's see how it affects cyclone formation. Whether tropical or not, cyclones frequently intensify due to the warm water and temperature disparity at the Gulf Stream's edge. Normal ocean temperatures for the formation of tropical cyclones are above 26.5 degrees Celsius. Above the Gulf Stream, tropical cyclones frequently form, especially in July, and storms pass across the Caribbean on a westward course before either turning northward and curving towards the eastern coast of the United States or continuing on a northwestward course and entering the Gulf of Mexico. Such storms can produce powerful winds and significant damage to the southeast coastal regions of the United States. A recent instance you may recall is that of Hurricane Sandy, a hurricane crossing over the Gulf Stream that intensified in 2012. It has been observed that during the cold season, powerful extratropical cyclones forcefully deepen somewhere along the shallow frontal zone. Moreover, subtropical cyclones frequently form close to the Gulf Stream. Around this warm water current, similar systems occurred in the proportion of 75% reported between 1951 and 2000, with 2 yearly peaks of activity happening in May and October. In the Gulf Stream, cyclones form within the water itself and can reach as deep as 3,500 meters, 11,500 feet below the surface. The Gulf Stream is contained by the AMOC, which is at its weakest point in more than a millennium, and recent research suggests that the AMOC may already be on the verge of shutting down completely. According to a recent study, climate scientists have discovered early warning indications that the Gulf Stream is gradually collapsing, suggesting that it may have already been losing stability over the past century, and that this could have serious repercussions on the Earth and its inhabitants. This prominent Atlantic Ocean current that is a part of the Atlantic Meridional Overturning Circulation (AMOC), which moves cold water south at the ocean's surface while bringing warm water masses from the tropics to the north, undoubtedly affects weather patterns throughout the planet, making the effects of a hypothetical collapse even more hazardous. The collapse of the AMOC system could be influenced by several variables, including freshwater influx, which is also closely related to climate change. Also, the quantity of fresh water pouring into the sea rises as the Greenland ice sheet melts. Because fresh water is lighter than salt water, it helps to keep water from sinking to the ocean floor, which is essential for the AMOC to continue moving. It's possible that the Gulf Stream and other main Atlantic Ocean currents have become less stable during the past century, and recent studies have alerted the world. The AMOC, which is primarily responsible for the comparatively moderate temperatures in Europe, is also responsible for moving warm water masses from the tropics south at the ocean's bottom and cold water north at the ocean's surface. Also, because it affects weather patterns throughout the planet, a possible breakdown of this ocean current system could have serious repercussions. Now, let's look at AMOC and the loss of dynamic stability. The AMOC is currently at its weakest point in more than 1,000 years, as previously demonstrated. The observed weakening's relationship to a change in the main circulation state or to a true loss of dynamical stability, however, has remained unclear. And the difference is significant because it would indicate that the AMOC has reached its critical barrier, beyond which a significant and almost certainly irreversible change to the weak mode could take place. Despite the lack of long-term observational data on the AMOC's strength, the Atlantic Ocean sea surface temperature and salinity patterns clearly exhibit the AMOC's so-called fingerprints. A thorough investigation of these fingerprints in 8 different independent indices suggests that the AMOC deterioration during the last century is indeed likely traceable to a loss of stability. The research supports the judgment that the AMOC reduction is not just a fluctuation or a linear reaction to increased temperatures, but instead indicates the approaching of a critical threshold beyond which circulation system could collapse. The phenomena are probably influenced by several variables that further the direct impact of the Atlantic Ocean's warming on its circulation. And some of these include the inflow of fresh water caused by the melting of the Greenland ice sheet, the melting of the sea ice, rising precipitation, and river runoff. Because fresh water is lighter than salt water, it has a lower inclination to sink to higher depths, which is one of the causes of overturning. Some people believe that the overabundance of fresh water that was introduced over the last century could have caused the overturning circulation to already exhibit such a response. To determine how far or how close the AMOC is to its critical threshold, we urgently need to reconcile our models with the empirical information that has been provided. So what would be the Gulf Stream's effects on Europe? Some movies are based on true stories of people's past experiences, while other movies have proved to be an announcer of what could happen in the nearest future. Take, for instance, The Simps. If you're familiar with The Simps, you'd agree with me that they've predicted the future several times. I mean, what they acted actually came to pass. However, bringing us back in course, do you think what happened in the movie Day After Tomorrow could actually happen anytime soon? If it does, what would be the impact on Europe and the world? The possibility of the Gulf Stream collapsing has ignited widespread media interest after a scientific report on it was published towards the end of February 2021. So let's see its possible effects. The stabilizing force that has enabled the Mediterranean farmers to cultivate their crops for generations is expecting a significant transformation. And the first locations to encounter this brand new erratic climate phenomenon that's spreading quickly throughout the Mediterranean basin are Spain and Italy. It's all a result of the persistent weakening of the strong Atlantic Ocean currents, which transport massive amounts of warm water from southern and central latitudes to the European coast. Gian Maria Cennino, an oceanographer and the director of the Climate Modeling and Impact Laboratory at the Italian National Agency for New Technologies, Energy and Sustainable Economic Development, said that the evidence of the AMOC diminishing is important because it informs the world that the temperature differential between seas in tropical areas and those in the northern polar region is closing. Warm waters are drawn to the colder northern area of the ocean, forming a stream that has been crucial in controlling the Earth's temperature for millennia. Oceans are the most important climate regulator, hence it is the driving force behind Earth's climate, and these oceans hold 93% of the heat that's produced by global warming. While changes in the atmosphere begin to occur suddenly, they have a significant impact on populations and crops and are plainly apparent. Those in the oceans are harder to perceive because they develop gradually, but have profound effects on the entire system for far longer periods. A more rapid increase in sea levels off the coast of the United States, chronic droughts in West Africa, and significant cooling of northern Europe might all be caused by significant changes in the AMOC. The Mediterranean basin will be the first area to experience the change, though numerous additional repercussions are also anticipated. Climate scientists have shown that southern Europe is a very distinct climate hotspot, where the effects of climate change are particularly pronounced and occur earlier than elsewhere. The Mediterranean Sea has historically provided the basin and its crops with a moderating influence. The climate in Rome is noticeably different from Boston since Rome is situated in the middle of a sizable lake. The Azores, a high-pressure weather system that affects the temperature of Europe and North Africa, is nearly gone as a result of the diminishing AMOC, according to regional climate data that we use to compile the Intergovernmental Panel on Climate Change (IPCC) report from the United Nations. The Azores creates fairly warm seasons that are favorable for farming and agriculture during the summer by keeping the cooler northern air masses far from the hot African circulation. Therefore, if a breakdown in the system occurs, it's going to affect farming activities and also increase the level of heat amongst others. Now, climate predictions indicate that it's extremely unusual for the overturning circulation to collapse, therefore Western Europe would not quickly enter a new ice age, as shown in the Hollywood movie The Day After Tomorrow. In fact, it takes at least a century for such severe changes in the climate system to take place, such as the creation of an ice cap over a sizable portion of Europe. However, on the other hand, it might cause a regional cooling that lasts a few decades before warming resumes in some regions of Europe, slowing down global warming there. But there is no question that the models are correctly anticipating warming on a worldwide scale. However, it should be understood that a significant change in overturning traffic has modest seasonal effects on the climate. Frankly speaking, the impact of ocean heat exchange is greater in the winter than in the summer, particularly for the northwestern regions of Europe that considerably benefit from ocean heat transfer. This implies that even if circulation were to decline, summertime heat waves would still be quite intense, and a major decline in overturning circulation in West Africa could result in severe droughts, particularly in the Sahelian and sub-Saharan zones. These crowded regions could be the most susceptible to changes in the circulation of the ocean. Now let's look at how the Gulf Stream affects the troposphere. Large amounts of heat are transported by the Gulf Stream from the tropics to middle and high latitudes, which has an impact on meteorological phenomena like cyclogenesis and low cloud development. On monthly and longer durations, its climatic influence is still poorly understood, and the warm current's impact on the free atmosphere above the marine atmospheric boundary layer is particularly ambiguous. Using necessary measures to analyze operational meteorological data, satellite observations, and an atmospheric general circulation model, we can now talk about the impact of the Gulf Stream on the troposphere. Findings show that the entire troposphere is impacted by the Gulf Stream. Sharp sea surface temperature gradients and atmospheric pressure changes in the marine boundary layer cause surface wind convergence, which stabilizes a condensed band of precipitation along the Gulf Stream. Very low cloud top temperatures are frequently observed in this rain band, which supports the idea that upward motion and cloud formation extend into the upper troposphere. These mechanisms offer a means for the Gulf Stream to influence the atmosphere locally and perhaps even farther away by inducing planetary waves. However, the discovery of this channel may have ramifications for our comprehension of the mechanisms underlying climate change, because the Gulf Stream is the upper limb of the Atlantic meridional overturning circulation, whose strength has fluctuated in the past century and is anticipated to decline in the future as a result of human-caused global warming and other factors. So what are the effects of the Gulf Stream and the overturning circulation? As opposed to commonly held beliefs, the Gulf Stream is not primarily responsible for the pleasant winters in Brittany. They are mostly caused by the global atmospheric circulation, which forces the average wind in New York to come more from the north and the wind in Brittany to come from the tropical Atlantic. Yet these winds pass over the Gulf Stream, rely on its warmth, and eventually take the position of the Gulf Stream into account. As a result, the Gulf Stream does indirectly affect the climatic condition in Europe. Nevertheless, the Gulf Stream, on the other hand, has major local effects that affect things like sea level, coastal ecosystems, and fishing resources, amongst others. Transferring the excess solar heat absorbed at the equator to the poles is one of the primary ways that the ocean affects the temperature of the planet. And by absorbing heat in the ocean and moving it from the equator to the high latitudes, the Gulf Stream and the overturning circulation help in the achievement. This is the sole reason why changes in the latter affect the global climate, leading to a stronger overturning circulation that will result in a warmer than usual North Atlantic and a cooler than usual South Atlantic. Such variations in ocean surface temperature have effects on tropical precipitation, particularly where the African monsoon occurs, and the precipitation that goes along with it, as well on the formation of tropical cyclones. The overturning circulation also plays a significant role in the storage of some of the carbon dioxide produced by human activity in the ocean's depths, which is important in the context of the amplification of the greenhouse effect and climate change. And the overturning circulation, in addition to its effects on the climate, has a significant impact on marine ecosystems through the vertical mixing of dissolved gases, particularly oxygen, and the horizontal transfer of nutrients. Conclusively, we can say that changes in ocean circulation will have an impact on biodiversity by affecting temperatures, precipitation, extreme weather events, and marine and terrestrial ecosystems. And naturally, all of this will have an impact on human societies. The complexity of climate change, which is not just about temperature change, is obviously demonstrated by this issue. Now, what could happen if the Gulf Stream was slowed down or stopped altogether? Several news outlets have written about the potential for a Gulf Stream collapse. The IPCC's sixth assessment report expressly addressed this problem and concluded that according to model predictions and theoretical understanding, the Gulf Stream will not stop flowing in response to global warming. Even if the Atlantic meridional overturning circulation, AMOC, is predicted to weaken and eventually collapse, the Gulf Stream will continue to flow. An increase in sea level among the North American coast, decreased precipitation in the mid-latitudes, altered patterns of heavy precipitation around Europe and the tropics, and greater storms in the North Atlantic are just a few of the repercussions that this slowing will have. There would be a severe shortage of food in India, South America, and West Africa in the case that the AMOC collapsed. Europe would experience more storms, colder weather, and there would be a rise in sea level off the eastern coast of North America. And the Antarctic ice sheets and the Amazon rainforests would both face increased threats. How near the system is to total collapse cannot be determined because of the complexity of the AMOC and the uncertainty surrounding future global warming brought on by tipping points. Even while many have speculated that it could happen within the next few years at the earliest, scientists believe there is no way to predict when it will happen and that it may take several millennia.